students, welcome you all to Think Maths. We are in class 10 Maths, chapter 8, Introduction to Trigonometry. In this session, we are going to discuss about the example problems 1 to 5. So these examples are related to trigonometric ratios. So before moving to the example problem, let us see what is Pythagoras theorem. So what is Pythagoras theorem? It is nothing but in a right angle triangle ABC. So let us take this triangle ABC. So this is right angled at B. So if it is so, we have one relationship. So what is that? So what is the side opposite to 90 degree? The side opposite to 90 degree is hypotenuse H. And suppose this angle A is given. Opposite to this angle is opposite side and the other angle is adjacent side. So the relation in Pythagoras theorem is nothing but hypotenuse square equal to opposite square plus adjacent square. So what is hypotenuse? Hypotenuse is AC square. So AC square equal to what is opposite? Opposite is BC square. BC square plus adjacent. Which is adjacent? Adjacent is AB. So AB square. So hypotenuse is AC square. So AC square equal to AB square plus BC square. So this is the Pythagoras theorem. That is nothing but hypotenuse square equal to opposite square plus adjacent square. Okay, children. So let us move to the example. Example 1. Given tan A is equal to 4 by 3. Find the other trigonometric ratios of angle A. So here one of the ratio is given, that is tan is given. We have to find sine, cos, cosecant, secant and secant. So if sine and cos are found, then we can easily find cosecant, secant and cot because all are inverse of sine, cos and tan. So first let us draw the triangle A, B, C. Here tan A. So A is given, angle A is given. Angle B makes 90 degree. So opposite to 90 degree is hypotenuse. Opposite to this angle A is opposite angle and this is adjacent angle. Okay. So now we have to find out the other ratios. So what is given? Let us start the solution. So it is given that tan A is equal to 4 by 3. So what is tan? We know the relation. Some old hippie caught another hippie tripping on acid. So S stands for sine. So sine is equal to old hippie. So O by H. O by H. And C stands for cos. So cos is equal to A by H. So underlined word adjacent by hypotenuse and T stands for tan. So tan is equal to O. O stands for opposite and A stands for adjacent. Okay, children. So these are the relations we already studied. Now we are going to use this relation. So tan is nothing but opposite by adjacent side. So this is capital A. So opposite by adjacent. What is opposite? Opposite is nothing but BC. So BC by adjacent. So who is adjacent? Adjacent side is AB. So now we get BC by AB is equal to 4 by 3. So it is given. So let us assume that this ratio BC equal to 4K because after simplifying we are getting 4 by 3. So it can be of the form 4 into some value divided by 3 into some value. So let this value be K. So BC is equal to 4K and AB is equal to 3K. So we have assumed this. Now we have to find out the other values. To find out the other values, we need AB, BC and AC. So AB is equal to 3K and BC is equal to 4K. Now we have to find out AC. So by Pythagoras, that is by Pythagoras theorem, it is PGT. So by Pythagoras theorem, hypotenuse square. So hypotenuse is AC square equal to adjacent square plus opposite square. So AB square plus BC square. So what is AC square? Which we need to find out. AB square. So AB is 3K. So 3K whole square plus what is BC? BC is 4K whole square. So 3K square is 9K square. 3 square is 9. K square is K square plus 4 square is 16K square. So it is equal to 9 plus 16 is 25K square. So we got AC square equal to 25K square. So if you take square root on both sides, we'll get AC is equal to 5K because square root of 25K square. So 25 is nothing but 5 into 5 and k square is nothing but k into k. So if in square root, if the numbers appear in pair, the answer will be that number. So here the number is 5. So the answer will be 5. Here k appears in pair. So if the square root of k into k is k, the number will appear here. So it is 5k. So AC is equal to 5k. Now we have to find out the ratios. So what are the ratios we need to find? We need to find sine A. So sine is opposite by hypotenuse. So opposite side is BC, hypotenuse side is AC. So what is BC? BC is equal to 4K. What is AC? AC is equal to 5K. So K gets cancelled. So it is 4 by 5. So sin A is equal to 4 by 5. Next we have to find out cos A. So cos is nothing but adjacent by hypotenuse. So adjacent side is AB divided by hypotenuse is AC. So what is AB? AB is 3K. So 3K divided by AC. What is AC? AC is 5K. So K gets cancelled. So the answer is 3 by 5. So we found sine, cos, tan is already given. So if these values are found out, then we can easily find out cosecant, secant and tan. Why? Because cosecant is nothing but 1 by sine A. So let me write here. Cosecant A is equal to 1 by sine A. 1 by sine A means it is inverse. So sine A is 4 by 5. Then it will be 5 by 4. Just write the inverse of sine A. So secant A is nothing but 1 by cos A. So what is the inverse of cos A? 3 by 5 will become 5 by 3. So cot A is equal to 1 by tan A. So what is tan A? Tan A is equal to 4 by 3. Inverse of 4 by 3 is 3 by 4. So we found all the ratios, cot ratio, secant, cosecant, sine and cos. So cos A is 3 by 5. So sine A is equal to 4 by 5, cos A equal to 3 by 5, tan A is equal to 4 by 3, cosecant A is 5 by 4, secant A is 5 by 3 and cot A is 3 by 4. So these are the values for all the trigonometric ratios. So let us move to next example in the next page. Example 2. If angle B and angle Q are acute angles such that sin B is equal to sin Q, then prove that angle B is equal to angle Q. So here it is given that angle B and angle Q are acute angles. So let us take two right angles and name it as A, B and C. So A, B, C. Another triangle is P, Q, R. So it is given that sin B is equal to sin Q. So what we have to prove? We have to prove angle B is equal to angle Q. So if you want to prove angle B is equal to angle Q, we have to prove that this triangle ABC and triangle PQR are similar. So if we prove the similarity, then we will have angle B is equal to angle Q. So to prove the similarity, we are going to use SSS criteria. That is side, side, side criteria. So we should prove AC by PR should be equal to AB by PQ and BC by QR. So these three ratios should be equal. So then by SSS criteria, we will have triangle ABC similar to triangle PQR. So now let us start the solution. So what is given? So it is given that angle B and angle Q are acute. So this is one point given. Another point is sin B equal to sin Q. So we have to prove angle B equal to angle Q. Now what we have? So there are two angles B and Q. So with this angle, we are going to define the ratios. Angle A is equal to 90 degree and angle P is equal to 90 degree. So in this triangle ABC, angle opposite, so that is opposite to 90 degree is hypotenuse and opposite to angle B. So this is opposite side and this is adjacent side. Okay. So in the same way, opposite to 90 degree is hypotenuse, opposite to angle Q. So this is opposite and this is adjacent side. So what are the ratios we know? So sin B. Let us start the proof. So it is given that sin B is equal to sin Q. So in triangle A, B, C. So we have to find out the value of sin B. So what is sin? So we already saw that this some old hippie. So S is equal to opposite by H. Old hippie. So O by H. Opposite by hypotenuse. So who is opposite here? Opposite is AC. So O is AC. So opposite is AC, who is hypotenuse. Hypotenuse is BC. So sin B is equal to AC by BC. Now we have in triangle PQR, who is given sin Q. So what is sin Q? Sin Q is also opposite by hypotenuse. So what is opposite here? It is PR divided by who is hypotenuse? It is QR. Hypotenuse side is QR. So it is given that sin B is equal to sin Q. Let us assume this as 1. So 2 and this is 3. So what happens from 2, 1, 2 and 3? From 1, 2 and 3. So since sin B is equal to sin Q, these two ratios AC by BC and PR by QR will be equal. So we can write AC by BC equal to PR by QR. Now what is the similarity we have to prove? We are going to use SSS criteria. So in SSS criteria it is AC by PR. So let us bring this PR here and take the BC to the other side. So this implies AC by PR equal to, take this BC to the other side, it will become BC by QR. That is, if PR is changed to left hand side, PR is in numerator, so it will come to denominator. Here BC, so BC is in denominator. When I change to right hand side, denominator will go to numerator. So we will get AC by PR equal to BC by QR. So let us assume that this ratio AC by PR and BC by QR be K. So let this ratio be K. So where K is a positive integer. Okay children. Now we have to prove the other ratio. So who is the other ratio? We proved AC by PR is equal to BC by QR. Now let us take this adjacent AB and PQ in the next page. In the previous page, we got AC by PR equal to BC by QR equal to K. Now we have to find out the value of AB by PQ. So let us find out the value of AB and PQ and check whether AB by PQ is equal to K. So to find out AB and PQ, we are going to use the Pythagoras theorem. So by PGT, that is by Pythagoras theorem, what we have? Hypotenuse square. So hypotenuse is BC square equal to is sum of the squares of other two sides. That is AB square plus AC square. AB square plus AC square. We need AB square. So what will be AB square? Keep this AB square as such. We have on the other side BC square. This plus AC square will become minus AC square. We need AB. So if we take square root on both sides, so this is in negative sign is there in between. So we cannot take this power 2 outside. So as such, write as such. So BC square minus AC square. So here only one term is there. So this power 2 gets cancelled. So it is square root of AB square, which is equal to AB. So AB is equal to square root of BC square minus AC square. Now what is BC? So BC is nothing but K into QR. So from this BC is equal to, so this QR when we bring to other side, denominator will go to numerator. So K into QR. In the same way AC. So AC will be equal to, this PR will go to numerator. So we get K into PR. So we can write this as square root of, instead of BC we can write K into QR. So K QR whole square minus, instead of AC we can write K PR whole square, which is equal to AB. So now AB will be equal to square root of, K square is common for both. So this is nothing but K square QR whole square minus K square PR whole square. So k square is common for both. So let us take k square common. So next that will be qr square minus pr square. So square root of k square. So if in square root some term is in pair, we will get the answer as that term. So k square. K square is nothing but k into k. K into k, square root is k. So k root of qr square minus pr square. So this is the value of AB. Now we have to find out the value of PQ. So how do we find? In the same way, by Pythagoras theorem, we have hypotenuse square. So QR square equal to PQ square plus PR square. So PQ square plus PR square. We need PQ. So keep this PQ square as such. On the other side we have QR square. This plus PR square will become minus PR square. Now the next step is we have to take square root. So if we take square root, on the other side it is PQ square. So PQ square will become PQ. So this power 2 gets cancelled if we take square root. Here this power 2 cannot be cancelled as this power 2 is in subtraction. So if there is some arithmetic operation between them, we cannot cancel this power 2. So it will be QR square minus PR square. So we got AB value as well as PQ value. Now AB by PQ. So AB value is K root of QR square minus PR square. What is PQ? PQ is nothing but square root of QR square minus PR square. So if you cancel both this, we will get K. So we got AC by PR equal to BC by QR equal to AB by PQ is equal to K. So if these three ratios are equal, then by SSS criteria, we get the similarity. So which can be written in the next page. So far we got AC by PR equal to BC by QR equal to K and also AB by PQ is equal to K. Now we have all the three sides are proportional. That is, we have AC by PR equal to BC by QR equal to AB by PQ. So then what we know? We know that a similarity triangle, if in two triangles sides of one triangle are proportional to the sides of other triangle, then their corresponding angles are equal and hence the two triangles are similar. So this is nothing but yes criteria. So which we studied in the previous chapter 6 in triangles. Okay. So using this theorem, we can say that triangle ACB is similar to triangle. For AC it is PR. PR. For B it is Q. So it is PRQ. Okay. So now from this we can say that angle B. So in angle B is in third place. So what is in the third place? It is Q. So this implies angle B equal to angle Q. This is by yes criteria. Okay children, I hope you can understand this example. So moving on to the next example in the next page. Example 3. Consider triangle ACB right angled at C, in which AB is equal to 29 units, BC equal to 21 units and angle ABC equal to theta. Determine the value of cos square theta plus sin square theta, cos square theta minus sin square theta. So here some values are given. There is a triangle ACB. So this triangle is right angled at C. So let us mark this as A and this is ACB. So angle C is 90 degree. AB is equal to 29 units. BC equal to 21 units. Angle ABC, this value is given. So this is theta. We have to find out cos square theta, sin square theta values. So if we substitute the values, we will get the answer. Now to substitute the values, we should know the value of AC. So here this angle 90 degree, opposite is hypotenuse. So this is hypotenuse, angle opposite to theta. So this is opposite, I'm sorry. So this is opposite and the last side is adjacent. So we have marked the opposite side, adjacent side and hypotenuse. Now to find AC. So the first step is to find AC. So how do we find AC? We have to use Pythagoras theorem by PGT. So by PGT, hypotenuse square. So AB square will be equal to AC square plus BC square. AC square plus BC square. So what is AB square? AB square is 29 square. AC square we don't know. What is BC square? It is 21 square. We need to find out AC square. So keep this AC square as such. On the other side we have 29 square. This plus 21 square will become minus 21 square. So this is of the form A square minus B square. So what is A square minus B square? It's nothing but A plus B into A minus B. So I hope you can remember this formula. Now we are going to use this formula. So this is A square minus B square. So A is 29 and B is 21. So A plus B, 29 plus 21 into 29 minus 21 equal to AC square. So what is 29 plus 21? It is 50. 29 plus 21 is 50. 29 minus 21 is 8. So 50 into 8 equal to AC square. 50 into 8 is 400. So 400 equal to AC square. So what is AC? So AC is equal to square root of 400. So if we take square root on both sides, power 2 gets cancelled. So AC square will become AC after taking square root. So this root 400 is nothing but square root of 20 into 20. So if the number is in pair, we will get the answer as number 20. AC is equal to 20 units. Now we got AC is equal to 20 units. Now what is sine theta and cos theta? So sine theta is nothing but opposite by hypotenuse. So yes, old hippie. So opposite by hypotenuse. So which is the opposite side? AC. Which is the hypotenuse side? AB. So AC by AB. So what is AC? AC is equal to 20. AB is 29. So what is cos theta? So cos theta is equal to some old hippie caught another hippie. So A by H. So which is A? It is BC, which is H, AB. So BC is equal to 21, AB is equal to 29. So it is 21 by 29. So we found out the value of sine theta and cos theta. Now we have to substitute in this cos square theta plus sine square theta. So let us do that in the next page. This page we got sine theta is equal to 20 by 29, cos theta is equal to 21 by 29. Now we have to find out the values of the first question and the second question. Now the first part is cos square theta plus sine square theta. So what is cos theta? Cos square theta is nothing but cos theta whole square. So cos theta is 21 by 29 whole square plus sine theta is 20 by 29. So sine square theta 20 by 29 whole square. So in the denominator we have 29 square. So take the LCM as 29 square. So in the numerator we will have 21 square plus 20 square. So that is a trick to find out the values of the squares easily. So what is the trick? So suppose we need to find 21 square. We have to make this 21 to the nearest tens place. So the nearest tens place is 20. What we have to do? We have to subtract 1. So if we subtract 1, we will get 20. So there should be another number with this product. So that number should be addition of 1. So already we subtracted 1. Another number is adding of 1. So 21 plus 1 is 22. So what we get? So write the 0. 2 into 2, 4. 2 into 2, 4. So we have to add a number with this. That number is the square of this number. So 1 square is 1. So the answer is 441. So 21 square is 441 plus what is 20 square? 20 square is nothing but 20 into 20. So write this 2 zeros, then 2 into 2 is 4. So answer is 400. In the same way, we have to find out 29 square. So who is the nearest 10 to 29? It is 30. What we have to do? We have to add 1. Another number should be minus 1. So if we add 1, we will get 30. If we subtract 1, we will get 28. So write this 0. 3 8s are 24. Balance 2. 3 2s are 6. 6 plus 2, 8. So which number we have to add with this? We have to square this number. So 1 square is 1. So the answer is 841. So 841. 29 square is 841. So 441 plus 400 is 841. In the numerator we have 841. In the denominator we have 845. So 841 divided by 841 is 1. So for the first part it is 1. So let us find out the values for the second part. Cos square theta minus sine square theta. So what is cos square theta? It is 21 by 29 whole square minus 20 by 29 whole square. So for both the values we have 29 square as LCM. So in the numerator we will have 21 square minus 20 square. So this is of the form a square minus b square. So 21 plus 20. A square minus b square is a plus b into a minus b divided by 29 square. What is 29 square? We already found out it is 841. So 21 plus 20 is 41. 21 minus 20 is 1. So divided by 841. So 41 into 1 is 41 divided by 841. So this is the answer for the second part. Okay children, I hope you can understand this example. Moving on to the next example in the next page. Example 4. In a right triangle ABC, right angled at B, if tan A is equal to 1, then verify that 2 sin A cos A equal to 1. So this is very simple and interesting. So what is given? Right triangle ABC. So it is right angled at B. So this value is B. So let us name this as A, B, C. They have given tan A is equal to 1. So this angle A is given, tan A is equal to 1. So now we have to name the hypotenuse. Who is hypotenuse? Opposite to this 90 degree is hypotenuse. Opposite to this angle. So it is opposite. The other side is adjacent. Now we have to find out the value of sin A and cos A and prove this ratio. So let us start the solution. So what is given? Tan A equal to 1. So what is the ratio for tan A? We know that some old hippie caught another hippie tripping on acid. So S for some, O for old, H for hippie. Caught, C, another A, hippie, H. Tripping. So it makes tan on, so O divided by acid A. So O by A. So tan theta is equal to opposite by adjacent. So tan A is equal to opposite by adjacent. So what is opposite? So opposite side is BC. So BC by what is adjacent? It is AB. So BC by AB is equal to 1. So on cross multiplying we will get BC equal to 1 into AB is AB. So we get BC is equal to AB. So let us assume this BC equal to AB. Let this value be K. So let us assume this. Let BC is equal to AB be K. Now we have 2 sin A cos A. So we have to find the value of sin A and cos A. So if we assume that BC equal to K and AB is equal to K. So from this we have to find out the value of sin A and cos A. To find out the value of sin A and cos A, we know BC, we know AB, we have to find out AC. So by Pythagoras theorem. What is Pythagoras theorem? Hypotenuse square. So hypotenuse square equal to opposite square plus adjacent square. So what is hypotenuse square? It is AC square. Opposite square is BC square. Adjacent square is AB square. So we have to find out AC. So BC square is K square and AB square is also K square. So we got AC square equal to K square plus K square is 2K square. Now I am going to take square root. So if we take square root on both sides, what happens? This power 2 gets cancelled. So AC will be equal to square root of 2K square. So in K square, power 2 gets cancelled. So we can write root 2K. So we got AC is equal to root 2K. Now we have to find out the value of sin A and cos A. So what is sin A? Sin is nothing but opposite by hypotenuse. So opposite side is BC. So BC by hypotenuse side is AC. So what is the value of BC? BC we assumed it as K. AC is root 2K. So this K gets cancelled. So we get 1 by root 2. Now cos A. So what is cos A? Cos A is adjacent by hypotenuse. So which is the adjacent side? It is AB. Which is the hypotenuse side? It is AC. So let me erase these ratios. So what is AB? AB is equal to, where did we find AB is equal to K? So K, AC is equal to root 2 K. So this K gets cancelled. So the answer is 1 by root 2. Now we have to find out the value of 2 sine A cos A. So 2 sine A cos A, which is equal to 2 into, what is sine A? It is 1 by root 2. What is cos A? This is also 1 by root 2. So 2 into, this is nothing but 1 by root of 2 into 2. Root 2 into root 2 is nothing but root of 2 into 2. If in the square root, the number is in pair, the answer is that number. So we have 2 into 1 by, so the answer is that number. So the number is 2. 1 by 2. So 2 into 1 by 2, this 2 gets cancelled. So the answer is 1. So we have verified that 2 sin A cos A is equal to 1. So this example is over. Okay children, moving on to the last example. Example 5. In triangle OPQ, right angled at P, OP is equal to 7 centimeter, OQ minus PQ is equal to 1 centimeter. Determine the values of sin Q and cos Q. So there is a triangle OPQ. So this triangle is right angled at P. So let me name this as P. So we have OPQ. So OPQ. So what is given? OP is equal to 7 centimeter. So this value is 7 centimeter and a relation is given. OQ minus PQ is equal to 1 centimeter. So let us start the solution. So what are the things given? OP is equal to 7 centimeter, OQ minus PQ is equal to 1 centimeter. So these are the things given. We have to find out the value of sin Q and cos Q. So now we are going to find out the values of this PQ and OQ using Pythagoras theorem. So by Pythagoras theorem, what we have? Hypotenuse square. So who is hypotenuse? The opposite to 90 degree is hypotenuse. Now this angle is given. Now let us assume angle Q is given. So they ask the values of sin Q. So angle Q is given. So opposite is PO. So this is the opposite side. The other side is adjacent. Now by PGT we have hypotenuse square equal to opposite square plus adjacent square. So who is hypotenuse? It is OQ. So OQ square equal to opposite side is OP. So OP square plus adjacent side is PQ. PQ square. Now what is OQ square? So we have OQ, OQ minus PQ equal to 1. So from this OQ is equal to, on the other side we have 1. This minus PQ will become plus PQ. So instead of OQ, I am going to write 1 plus PQ. So let us name this as 1. So from 1, we have, instead of OQ, 1 plus PQ whole square equal to OP square plus PQ square. So this is nothing but A plus B whole square. So what is A plus B whole square? A square plus 2AB plus B square. So applying this formula, A square, so it is 1 square, which is 1, plus 2AB. 1 into PQ is PQ. So 2AB plus B square. So it is PQ whole square, which is equal to OP square plus PQ square. So both sides we have plus PQ square. So this both gets cancelled. So if there is same value with the same side, the value gets cancelled. So the remaining is 1 plus 2 PQ is equal to OP square. What is OP square? OP square is 7. So it is 1 plus 2 PQ is equal to 7 square. So 1 plus 2 PQ equal to 49. 2PQ is equal to 49 minus 1. So PQ will be equal to 49 minus 1, 48. 2 is in numerator, that is product. It will come to division. So 48 by 2, we have 24. So we got PQ is equal to 24. So we are going to substitute PQ is equal to 24 in 1. So if we substitute, we get OQ is equal to 1 plus 24, which is equal to 25. So we got all the values. OQ is 25, PQ is 24. So we can find out the value of sin Q and cos Q. So what is sin Q? I think you are all familiar with the ratios. Sin Q is nothing but opposite by hypotenuse. So who is the opposite side? OP. Hypotenuse side is OQ. So OP is nothing but it is given 7. So 7 by OQ is 25. So sin Q is equal to 7 by 25. In the same way, cos Q is equal to adjacent by hypotenuse. So adjacent side is PQ, hypotenuse side is OQ. PQ is equal to 24. OQ is equal to 25. So cos Q is equal to 24 by 24. 25. Okay children, I hope you can understand all the problems and thank you for watching.